Hello and welcome to another tutorial. So this time around I'm going to be talking about how to create your own packages, in particular packages that you can use with the Unity Package Manager. So in terms of why you might want to do this, so there's a few different reasons. So for example, there's a couple of cases why I do this. For one thing, there's a lot of reusable code I create as part of these tutorials, and I want to make it easy for people to be able to use it in their own projects without having to download a Unity project and extract it out of it. So providing some of those things as a package makes it really easy for others to make use of. I also make use of this for just my own stuff for internal libraries. And again, for a similar reason, it makes it very easy for me to have a set of common code that I'm forced to keep modular and then to bring that in quickly into other projects. So it makes life a lot easier. You could maintain it in a separate repository, things like that, and bring that in, fork it, all those sorts of things. And I did that for a while, but I think the package manager approach gives a bit of a neater setup for it. So what I'm going to do is I'm going to show you how I go about creating packages. Now there are different ways of doing this, but the way that I'm going to show you is how I structure it for when I want to be able to have the code easily able to be tested and also be able to, turn that into a package. So I'll run through a bit of the process there. So I've already created a blank Unity project, and what I'm going to do is set up a couple of things, and I'll show you sort of why I'm setting up things the way that I am, and I'll explain sort of what the setup process is here with this. So the first thing that I recommend doing is having a folder here and having your appropriate name for the package. So we group everything under this. Now, with the packages, there are a couple of key sort of folders that you need to have, and it is important to actually divide stuff up into these folders. So you need, if you have any code that would normally go in an editor folder, that has to exist under this parent editor one. You have another folder called runtime. So this is where your general sort of actual runtime game side code would sit. You can then set up a folder for tests. So if you have unit test cases. Now under tests, we do again need to split out the difference here between ones that are editor side and ones that are runtime side. So that is an important aspect in terms of how it's split out. Now, we have folders for documentation. Now, if you look at the Unity guide for the package layout, you will see that it indicates the folder name for this should be documentation tilde. And that's something where I don't want to have the tilde in there normally. The reason being is that Unity will actually not track that folder. It ignores that entirely. So I'm just going to call it documentation. And the same thing is actually true for samples. Samples in our actual package will need to have a tilde at the end of it, but for our testing purposes should not have a tilde. So, okay, that is the broad layout in terms of folder structure. Now, there are a number of key files that we need to actually have here. So I'm going to open this folder, And if we take a look here, the general files that I need to create, and I'm going to create this as a new text document. If you can't change the extension if it's not showing, then you might need to turn that option on in your whatever you're using as your file explorer, depending on the platform. So you need to be able to see the file extensions. But the key ones we need to have is a package.json, and it will get we will get that prompt in terms of renaming the ones, which is fine. We have a readme.md, so that uses the markdown notation. Now, I don't know if the files are case sensitive. I haven't tested not following exactly the case they use. I would recommend just sticking with the exact case they use. The changelog.md. We also have another file, and this one is our license MD. And then finally, we create another one, and this is third-party notices, again, .md. Most of these documentation-related ones will have the .md extension, so that's an important thing there. Now, we'll get to the content that needs to go in those files shortly. There's a couple of key important things in terms of our code setup that really matter. So if you are going to have any scripts, then you need to have an assembly definition. So I can go to create, and then we have an assembly definition. So demo, I'm going to call this demo package runtime, like that. Now, you might want to, if you're doing this right at the very beginning before you've created any code, you might actually want to set the root namespace at this particular point. That can be really handy because it means if you create scripts afterwards, they will actually automatically get that assembly, that sort of namespace added to it, which is really handy. So runtime, if we have runtime files, then we need to create that assembly definition. If we have scripts in the editor folder, same thing applies. We need to also create a assembly definition. And important thing for this one is that it should be our editor one. So this should be fine as it is, but we may find that we need to make further modifications to that. But we create these. This will allow us to safely create scripts and have those work. And if you don't have those assembly definitions, it can fail in a really obscure way when you import the package. So what can happen is, so you haven't created the assembly definitions and you have a demonstration scene that uses one of your scripts from the package. It will quite likely show the script attached in the scene, but when you go to run it, it won't actually work. It won't be able to find it. You'll get missing script errors. So it fails in a really hard to spot way. So just creating those assembly definitions is really important. The same is true for any of these test folders. If we had code in either of these, each one, editor or runtime, that needs an assembly definition. One just at the top level of tests isn't sufficient. You create one inside each particular one. That's actually really important. Now, naming convention wise, there's different ways you could actually name this. Unity does recommend going for an approach where with the editor one, you actually put .editor. And actually using a company name .package name .editor. Same thing for the runtime one. Similar stuff for the tests. So like of the editor one here, if we created the assembly definition, this would be demo package, and following their convention would be editor.tests, like that. And I won't set a namespace for that currently. And then this one also have an assembly definition. This would be demo package.tests. So really important, make sure you do include an assembly definition for any of those folders there, the editor, runtime, or the test ones under tests that have code within them. Now for documentation, this is one where what I would do is I would, and I can't see my folder, there we go. Under the documentation, we could create a new document, and this would be demo package.md. So again, using the Markdown language, and we use the package name here for this. So just really important to follow these naming conventions. It's quite strict with those naming conventions, and having things even slightly wrong can cause some major issues. So very important that we get it right. Now let's create a couple of scripts here. So I'm going to create a folder, and this might just be, let's call this basic logic, for want of a better name. And I'll just create a script here, bounce. So I won't do anything with that. It doesn't really need any particular logic in it. We just want to make sure that we have a bit of script there. I won't bother setting up ones inside the editor or other folders. That's not necessary at this point. But if you did have any editor code, you just make sure it can go under subfolders under here. It just needs to be under the main root editor folder there. So let's look at getting some of these files actually sort of set up. So let's go for just go for Notepad for these. So a changelog. There is a specific structure of how you should be naming things in this and how you should be writing things. So the general structure is for each version, it uses semantic versioning. So that is major number dot minor number dot revision. Now there is a expectation of how those work. Minor number changes might add features, might update or extend features. It should not ever break any APIs. Revisions as well are just, should be bug fixes, minor additions. A change in the major version, so in that first number there, that can break APIs. So that's something where keep that in mind. So we have version number and we have the date. Now, the particular format you write the date in here isn't specified to avoid confusion, because different places order things in the date differently. I always just actually go for writing the month out in full. Makes it easy. Same with the year in full. Just avoids sort of any issues there. And then can just have the details here. I would always have the most recent version at the top, and then you don't delete older entries, you just add to the top of this file as you make changes. So for our changelog, that's actually all we need. There's nothing more to it than that. License, well, that's going to depend on the license you are wanting to use for your particular project. For mine, I'm going to bring in the MIT license. That's my preferred license for all of my stuff. But depending upon what you're working with, that might be different. So, but that's the file where you would be placing that. Then we get to a couple of the other ones. We'll do some of the sort of simpler ones there that we need to do for this. So we have readme. So this should be a description of what your package is. So this is, demo package illustrates how to create a UPM compatible package. I would say that should be as comprehensive as possible. You might want to be talking about API, things like that. You can go into more detail in that in the actual documentation. So here is where I would put detailed documentation for the package. And you might have multiple files there, but I would have the detailed documentation go there. Whereas this README one, I would keep that as a fairly high-level one. Now, third-party notices, you might not have any. So this file can be omitted if you don't actually have any applicable things here. What would go here is if there was a particular set of other code that you had included that had its own license, you, as well as including their license file, might need to mention that here. Attribution for any assets. This is sort of where you generally are going to need to sort of detail all of those types of things. So that's our third-party notices. One of the big ones is this package.json file. And this is a really important one. And the reason it's really important is because there is quite a lot of things that we can list in this. And I'm actually going to, as a starting point, paste in Unity's example one. I think that's a good starting point, and I'll talk through the different things here and how you would sort of modify that. So, first thing is you provide this unique name for it. So in this case, I'm going to put it as game dev education.demo package. Make sure you're being consistent with the naming case, things like that. Version here, well, my current version is 1.0.0. Can give the proper name for it. So this is a demo package for the Unity package manager. Now these two lines here, the Unity release isn't mandatory. This Unity field here is where you would indicate the major version that is sort of essentially the minimum. The minimum version of Unity someone has to have to actually use this package. I usually would put that to the most recent long-term support version. But you might want to have an older version. But if you are putting an older version, make sure you've tested it with that older version. It is really important to do that. Whatever version you're listing there, absolutely you must have tested it with that. I think it would be not a good idea to not do that. It's not really good for your end users because you are saying what version is going to work with this. The release is if you need to be very specific with what the minimum is. I generally haven't needed to be, so that is one that you can actually safely remove depending upon your particular requirements. Now, if you have web-based documentation, things like that. You can include a link to those. I usually don't and go for having it embedded in the actual package itself. So these can be used, or you can actually remove them. Now, I will come back to dependencies, but keywords. So you can provide a few keywords here. These should help people find what you're after. So demo, UPM, and it's kind of a template, so I think that's not an inaccurate thing. So in terms of the details that you provide here for the author, this section is actually completely optional. You don't need to include this, and you don't need to include all of the entries here. So I could include, game dev education, or I could put, my name. So what information you include there is up to you. Keep in mind, especially if this is a publicly released package, I generally don't put email addresses in there because that makes it way too easy to potentially be spammed. So I'm not going to generally put that in. But for, if you've got a dedicated support address, you might want to. That's something to keep in mind, is that what information you might want to provide there. Now, dependencies. This is an important one. You might have a requirement in your package for particular other packages. That's not uncommon. So, for example, quite a lot of mine would depend on TextMesh Pro. That's a very common one. And you want to ensure that a particular version of that's installed. So you need to provide the ID and a version number. Well, essentially, that's the minimum version. Now, if it's a package you've already got, then an easy way to find that is under the packages here. If you go to Show in Explorer, we can see in the package cache here. So for example, TextMesh Pro. I can see that I'm using TextMesh Pro version 3.06. So what I would do is I would copy this. I would go to here, paste that in, grab out the version number, remove the @ and do this. And I can just do that for every single package that I'm using. So this is why I always set up my packages within an existing Unity project, because it makes it easy to find whatever packages you want to actually have present. So, okay, that's a bunch of the stuff there. But samples are a common thing. So demonstrations of what your actual, library does. Or it could be additional functionality. So these appear in the package manager as in the sample section of additional things that people can add. So I'm going to add a demo sample 1. And here I'm going to create a scene. So demo sample 1. That test scene. And I am just going to create a cube, and I will attach the bounce script to that, just so we have something. Now, what I then put in the actual setup here for indicating those samples is I have a section here called samples, and it looks like this. So we have our square brackets, and then we have in this entries, and what we provide, we'll do tab, we have a display name. Oops. So display name, and this is going to be demo sample 1. Well, reorder that. That's a little better. So demo sample 1. So we provided the display name. We provide a description. And this, what we would say is demonstrates a simple sample with a script. And then we provide the path. Now, although the folder here, I don't have the tilde, right at this point, I will put in the tilde because that is where it is going to end up being. So we provide the actual path. So this goes under path. So samples, demo sample 1. So that gives us our essential structure for this. We've created all of the bits for the actual package. We have populated the contents of the file. This is something where, I would test running it, and it works, which is good. Kind of expected that it should, but we know for certain that it is working. So at this point, what I would do is I could commit these changes, and then I would set up the branch for the package manager. So for version control, I use git fork. It's my preferred one, but you'll be able to do this in any of the particular tools. The terminology might change slightly, but the general process should be the same. So what I'm going to do for safety, to make sure everything is saved, is I will actually close this demo sample now. And then once that's closed, and I know everything should be properly saved, I'm going to stage all of these files. Initial commit. Can commit that. So, okay, I've got that checked into the repository now. And then what I would do is I would create, because this is me doing the first initial setup of this, I would create a new branch. And I specifically call this in lowercase UPM. So I can create and check that out. So now we get to the reorganizing of this, because we do need to actually restructure the layout of this a bit, because that assets folder and everything like that, we don't want any of that. We want our demo package content here to actually be right at the top. So we need to change this around a little bit now. So what I'm going to do, and there's a few different ways that you could go about actually doing this, but essentially all of the content here needs to go to the top level and everything else needs to go away. So one option is I could grab all of this and I could drag it over like that. And then what I could do is, because I've got a git ignore that I kind of don't really want, what I could do is I would probably clean out that git ignore. Now, I could look at setting up, like I could nuke these other folders other than those particular ones, or I could create a new git ignore folder. And that's sort of what I'm leaning towards doing. So what I would do is things like the documentation are all good. The library folder, well, I would ignore all files in library. So I'll get a new git ignore. User settings, that's also one that should not go through. So I can ignore all of that. We do have things like the vsconfig, again, also should be ignored. We have our project file. I'm going to ignore that. And that's looking a lot better. Logs folder, again, another one that should be ignored. So we've thinned out most of the files here. Now, what I would do initially is I would actually not ignore that assets folder. The reason being is that I want to make sure I properly get the fact that the files have been relocated over. There's another project file that we can ignore. So that's looking pretty clean for the particular ones that we would include there. That looks good. The other change I do need to make, though, is we have a few folders that have to actually be renamed, if we remember. So samples has to actually go to samples with the tilde there. So that's important. And if we remember, the same thing was true for documentation. And I'm doing this before I stage any of the files, because I want to have that sort of history of everything properly preserved. So that looks good in terms of the layout. So I would stage all of this. And runtime, all of these ones. And I'm happy with all of those. So that's good. And we can see things like the documentation, all of those are properly showing up as moves. So that looks good to me. So this is initial UPM layout. So most things showing up as a move. I'll commit those. And then I just want to check with the actual folder here. I could delete that assets folder now because I have ignored it. And this would be one where this is something I would want to ignore. So the reason for deleting then the assets folder is I want to pick up any changes to that, because some files, like this meta file, we should actually ignore. So I'm going to ignore demo package meta, stage those, and update UPM to remove unneeded meta file. So that looks good. So just want to double check sort of the layout that I've got here. A lot of that is looking pretty good to me. So what I would do now is I would push this to the remote I've already connected. I want to push all of the branches, but I haven't. So I'm going to push master first, and then I will push the UPM branch. So then we push UPM. I might actually tag this as 1.0.0, so matching the version number to another push, make sure it's got the tags. So now, if I go to the repository, which we can see here, then I have the layout for it, this is not the UPM one. So if I switch over to the UPM one, then that layout looks pretty good to me. Everything there looks reasonably correct. So we want to look at then how we test this in a existing project. So I've created just a demo project here to test this in. So what I would do is I get the URL for it. So the same one we'd normally use for cloning. I go to the package manager and I can say install package from git URL, paste that in. Now it doesn't have the branch there, but if I add #UPM at the end of that, that will tell it to use that branch. Now this is where it might come up with errors. So the error with the package name, the most likely cause of this, and the general cause that I tend to see, is that the naming is actually requires you to have it be all lowercase. So what I can do is if I open this, I can easily test this. Game dev education. Now I would bump the version number here. So we've changed it to be all lowercase. I would set up a new version in our changelog, and that would be, so it's not breaking the API, but it is making a change, so I think good to update the version. Update or fix package name. That's good. So I've made those changes to it. So then we can see those here. I'm going to commit those. Fix package name. Then what I would do is again tag that. And we'll push that. So what I should now be able to do is I can test again for adding that in. Now, annoyingly, Package Manager does forget the URLs that you previously entered in. So you do actually need to re-enter that full URL. Conveniently, at least in this case, it does put the error up there. So now I can try this again. So hashtag UPM at the end of it. So we'll try this. So we can see we didn't get an error. Now, because I didn't fill out the author, we get an author unknown message. Now, if we take a look at some of the errors that we are getting here, so this is a thing that can happen. So there's a few ones that it's showing up errors for. And generally what it comes down to is issues with meta files being there that don't need to be. So for example, things like the samples and documentation one, we can see it's complaining about those. So again, we remove those meta files. So those won't be included anymore. So we can see a couple of other ones are also kicking off errors there. So there's potentially a few folders here. It's dragged in a few sort of meta files that shouldn't be there. So we can see there is this actual just empty license file there. So that shouldn't be present. So you can get a few stray files easily just appear in there that we do need to make sure get removed. So we've removed that. We did inadvertently end up with project settings in there. So I'm going to delete that. That was one that I missed in Git. So I will stage all of those removals. That should clean up a lot of the errors. which will be good. And then later on, we can always add in an exclude for the project settings folder. So that's good. I will do a version bump again for the changelog and for the actual package file. That will allow us to properly pick up any changes. So these are common ones that you can easily get these in, and some of these errors were intentional. Other of these errors were ones that I hadn't intended, but it's good to see the kind of errors that you can run into. Remove problem files. So we'll save those. Again, stage all of this and remove unnecessary files. Commit that. I will tag that again. That and push it. That's good. Now, what I would generally do for testing something like of this is I am going to actually remove the package from the project. And then I will actually re-add it. The reason for that is it's just a bit more of a reliable way of making sure that you are cleanly testing it. So install it from a URL, #UPM. So it's found it, it's installing it. Now we still got a couple of errors. So we can see there's a few things there still that we need to clean up, and that's okay. So first thing is removing this packages folder. So that will clean up a lot of the errors here. Most of the ones are actually complaining about that. Now we do have errors here for these assembly definition ones because there's not actually anything happening with them. So there's no scripts associated with it. So you would only include those assembly definitions in those folders if you actually had files in that. So that's something that's important there. I will leave those in there, so I'm okay with those warnings, just because I want this to be a useful template for people. So, okay, that's good. What I will do is copy that. I will remove the package again and clear these errors. And I will again update this. And another version. And this will also be removing unneeded files. So I do find, like, I've created several packages. It's still super easy for me to forget these files. So I think it's really useful to see the particular problems that can occur. Don't think I saved this file. Stage that. More cleanup. Commit that. Tag it again. 1.0.3. And again, we push all of that. So that should be now updated. So that looks a lot better. Let's test that out and make sure that it is happy. What we're looking to get to is the only errors that we have are the warnings for those assembly definitions we're not using. So we can install it. So that's good. We've only got those assembly definition ones. We can see the version history here. Can look at the changelog. That file will open up. which is good. You can see dependencies, and then we have our samples. So if I import that sample, again, we want to test, make sure we don't get any errors. If I go to that and load it, we can see the script is attached, and we also test running it. And so that works. So that's something where if you don't have the assembly definition, generally what you'll find is it won't actually run. So that's good. We have gone and set up our package there. We have made a bunch of updates to it for cleaning up things. We've tested it. We've seen the kinds of errors that you can run into with it. That's good. We have now created our package. We've got a structure that works. We've got a project we can test it in, which is good. And we've tested it out in our demo project as well, just to make sure it installs cleanly. Now, managing the stuff with the branches is still something that can be a little bit of a headache because we did change a couple of things. There were some key things that we did modify there, and merging this back is kind of a little bit of a tricky thing, and that there are a lot of changes we might not want to actually bring over. I will be honest, at this stage with how I bring changes over to the package version is, or vice versa, is I generally just after each commit, copy and paste. It's not an ideal workflow, but it's something where until I get a bit of a better workflow set up for it, that's the one that I find is the safest and most reliable, because I can be certain that the package has all of the files that I want in it. But dive on and experiment with this. See what things you might want to set up in your own packages and see how you find that goes for your workflow. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you've got any questions, chuck those in a comment below. There is a link to this package and the whole repo in the description as well. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye.